Thank you for the kind introduction. So today, my topic would be towards enabling agriculture 4.0 in Malaysia through GIS. So my pitch today will be focusing on the oil palm industry from Sandabi Plantation's own experience. So, however, I believe that most of the content will be presented here also will be applicable to other agriculture sector. Now let's have a look at the palm oil industry in Malaysia. Back in 2017, marked the 100-year anniversary of Malaysian palm oil industry. Back in 1917, this Frenchman, Henry Fauconnier, established Malaysia's first commercial oil palm estate in Tanah Maram, in Selangor, which happens to be one of Sandabi's estate. So my point here is that the industry not only has reached its comfort zone, but to my personal opinion, it has been in comfort zone for far too long. Let's have a look at some history on the Precision Agriculture Unit, the unit that I'm coming from. For those who didn't know that the current Sandabi plantation is actually a merger of these three major plantation company under Pemodalan Nasional Berhad, which is Guthrie, Golden Hope, and the old Sandabi. Right. We started off our journey in precision agriculture back in 1997. So we started off with mapping all of our boundaries in the estates using GPS technology and also GIS. So in 2004, Golden Hope start its journey in geospatial technology by starting a project with remote sensing and also GIS with the help of Malaysian Centre for Remote Sensing back then. So it has been 23 years since we are established, and to date we have 21 personnel with 10 scientists, 6 field staff, and 5 office staff. So the mission of Precision Agriculture Unit is to continuously providing reliable geospatial solutions to Sandabi Plantation to improve our operational efficiency. And our vision is to make Sandabi Plantation the industry leader in geospatial technology application for effective decision making. Now, for those who didn't know what the Agriculture 4.0 is, so we have to look at the root itself, which is the Industrial Revolution 4.0. Now, going back to the first industrial revolution, which is the steam technology back in 1784. And after that, the second industrial revolution is on with the introduction of electricity. The third one is through the introduction of computing technology. And today, the fourth industrial revolution is on the artificial intelligence. But in today's perspective, we will talk about location intelligence. When we talk about agriculture 4.0 or industrial 4.0, we cannot run from talking about drones, right? So it's a revolution. Everybody's talking about drones nowadays. So for us, we started our journey back in 2012, where we had this collaboration with University Putra Malaysia and also the University of Florida on multispectral imaging using a multi-rotor drone. And after that, we have numbers of POCs being carried out at our own test site in Selangor until 2014, when we decide to create our own operational team It is actually consists of three departments in Samdabi Plantation, which is the Plantation IT, Plantation Strategy and Innovation, and also Precision Agriculture Unit. So our current fleet consists of several drones, which is the Skywalker. We also have the Phantom 4, the Phantom 4 RTK, the Mavic 2 Pro, and also M600. Now, when doing a area imaging or aerial photogrammetry, GCPs are necessary to achieve the desired accuracy. Now, in order to do this, we have created a highly visible ground control points marker, which is unique to Samdabi, and it has been used as our standard operations. So this is what it looks like, and you can see how it looks like in the image. One of the key elements when you did the digital photogrammetry is you are able to create a digital surface model. Now, using ground control points, we are able to generate an accurate digital surface model or even a digital terrain model, right? So this digital elevation model, a digital terrain model are very important, like for us to do our planning. For example, this is an example of an impact from elephant intrusion in Sabah. So the drone image that we use for this case study is basically to find the impact or the extent of the loss of palm that we have encountered. Like for example, for this one, we ended up with having about 27 stand per hectare. So it's actually that extensive. So we will be able to advise the estates on this issue, and they will be able to accurately pinpoint where are the points that they need to supply. And of course, we are able to also generate the digital elevation model so that we are able to plan more accurately. Another example is on the flood simulation. So this is in Bukit Cheraka Estates, our UAS test site. Here you can see that we are able to simulate the low-lying areas. So we are able to assess the flood hazard, the vulnerability, and also the risk assessment. For agronomic assessment also, we are able to detect these agronomic issues. For example, this yellowing palm. It is actually not because of it is not being fertilized, but it is actually due to nutrient flushing at hill slopes, because at this particular terrace, the slope, I mean the terrace back slope has collapsed. So whenever fertilizer being applied at that particular area, it will be flush to the bottom, where you can see down at the bottom there, the palms are quite healthy. Another application is on the multi-temporal analysis, when we wanted to do some periodic monitoring time series. So you can see the difference between an image captured in 2013 and also 2014, where you can see changes from healthy palm to dead palm, and also from healthy to unhealthy. And because we have advised the estates on the vacant points, so the following year they have supplied those palms the vacant spots. Right. Next is the bund monitoring using drones. So for those who didn't understand what a bund is, it's basically an embankment or wall of impervious materials which forms the perimeter or floor of a compound and provide a barrier to the river or the sea. So this is basically a critical component, especially when your estate is sitting below mean sea levels like us in Carrot Island. So by using this digital elevation model, we're able to generate this 3D cross-section of the bund. So we'll be able to monitor the slope, the width of the bund, and also the height. And then we are able to advise the estates where are the critical area of the bund and for them to react upon it. Another potential application is in pest and disease. Like this one is for Ganoderma early detection, which is ongoing project of ours. So by using a multispectral image, you'll be able to see the difference where the RGB, the standard RGB camera cannot capture. Like for this one, in summary, we are able to, there are actually a potential of about 43% that we are able to detect Ganoderma at the early stage. Now, another application is on the geospatial replanting blueprint, again by using a digital elevation model. So we will be able to precisely identify those areas which required to be terraced. And we are also able to optimize the design of roads, the terrace, and also the planting point, just to optimize the quantity of palm seedlings to be planted. Now, with all this kind of data, it is only good if it's being shared and consumed by the stakeholders, right? For example, like the operation people and also the subject matter expert, like the agronomists, like the crop protectionists. So we believe that location gives you a powerful interpretation of data, and we can do that with GIS. But the thing is, to do that, we need to empower the entire organization with GIS. And most of them do not aware what GIS are. Yeah? So we've created this web GIS platform called SMART, which stands for Spatial Data Management and Rapid Analytics, which allow us to organize and share our work as a geospatialist on any device, anywhere, anytime. So the objectives are to create awareness through visuals in operational or research data for better insight, hence a better decision making, and to expand the reach to maximize the impact of GIS across the organization, because currently it's only limited to the GIS professionals, and to share a standardized set of geospatial data to ensure data reliability, which is managed by our team, the GIS professionals. And last but not least is to create a common platform of collaboration and continuous innovation on the existing data sets to resolve the evolving issues using location intelligence. You see, we are more interconnected to each other than what we thought we were, especially when 80% of all data has a spatial component. So the role of SMART here is basically to create a geospatial ecosystem within Sandabi plantations, where we are able to share all these map services with all the departments within the company. So it is basically consists of three major components, which is the operations dashboard, the field mobile applications, and web map applications. For example, this is our vision of a smart estate operations hub, where it started off with the manpower planning, where with our yield prediction coming from artificial intelligence and machine learning. And then we'll have our fertilizer application dashboard with embedded with the weather forecast. And then we can predefine the point of interest to identify or revisit any issues. And we can assign tasks using the Workforce app. And then the field supervision, moving towards the stakeholder engagement, where more effective and interactive discussion with the estate management and team can be done using operations dashboard. And also with the reports and recommendation, it will be a more effective way for us to tell the stories using story maps and use the location intelligence to improve the understanding of the issues for better reporting. And last but not least is we are able to monitor the progress of the assignments in the estates in near real time from our operations dashboard. So this is where we share all of our GIS layers with all the stakeholders. So all the GIS layers will be shared here, including the farm locations and the unplanted areas, the road, the drains, and everything. So this is a sample of our smart operation dashboard. This is our smart agronomic hub, where the agronomists will be able to log their issues using their smartphones whenever they are inside the fields. Also similar to the estate operation dashboard, where they are able to predetermine where are the points that they are going to visit through this vitality index dashboard. So they will be able to communicate better with the estate whenever they have ended their visit with the estates. And another thing that we have developed is the Smart Sustainability Hub, where inside there we have an application called the Crosscheck. It's basically an open source online traceability tool that is available to the public, and it actually provides transparency by tracking supply back to its source, identifying where the problem exists, and taking action. So this Crosscheck 2.0 is now available, and it's running on Juice Enterprise. So these are some of the view from our Crosscheck. And also the hotspot monitoring. These are the kind of dashboard. It is also connected to the field mobile application, where from this detection, we are able to send the alerts to the people on the ground to do verifications. And at this time of pandemic, we have also created this COVID-19 dashboard. It's basically used for to monitor our visitors coming in and out. Now, are we ready for all this? Like for us in Sandabi Plantation, this is just a beginning. Like to date, we have more than 30 applications to be developed within the next 3 years under the SMART initiative. And the numbers are growing once you have engaged with the users and stakeholders, right? And come into realization that in life we were never prepared for anything. Like when we were born, we cried, right? So yeah, it actually indicates that we are not ready to be born. In fact, like everything, the first day you go to school, uh, yeah, it applies to everything. So um, even though we'll never be ready for anything, but we have to be prepared for everything. Um so we have to embrace this agriculture 4.0, and we know it's going to be disruptive, but we have to prepare ourselves for it. So with that note, I end my presentation today. Thank you.